Welcome to qnawire.
We have a jumping spider going from a log as a function of height in centimeters, and time is in seconds. Okay, A, when does the spider land on the ground? The ground has a height of 0, so we set our function equal to 0. Now this is going to require the quadratic formula, so you can either use a program in your calculator, or there are plenty of them online, or you can do it by hand. I pulled off A, B, and C for you. So negative 490 for A, 75 for B, 12 for C. Okay, we're going to get two values here. We're going to get approximately negative 0.098 and 0.251. Okay, so this is a really quick jump if you think about it. So here's time and here's height. So remember, he's not starting on the ground. He's starting at 12 centimeters. And then he's going to go up, and then he's going to come down. And what this result is telling us is that at about a quarter of a second, so 0.25 seconds, he's already going to be on the ground. So when we're choosing a domain and range for this problem, given that the entire jump is over with in less than a quarter second, maybe start at 0 and go to 0.3. That would be plenty. And, have your scale either 0.05 or 0.1. Now, as far as the height goes, that's going to be your range. And he's not jumping that high if you think about it. He's really starting a couple centimeters off, and I don't think you would need much for height. So for height would be my range. I might go 0 to maybe 20 at most, and maybe a scale of 1. That should be absolutely plenty. In C, and if you want to be able to be sure you've got, that correct height here, you can find the vertex and look at the y coordinate, because that will give you the maximum height, so you'll know your range can handle that. So let's actually get that value so we can be sure. So to get the vertex, we want to take opposite of B over 2A to get the x coordinate, and then we want to plug that in to get the y. So opposite of B is negative 0.75, and we're going to be dividing that by 2A, so 2 times negative 490. It's going to give us a really small value. So we're going to get 0.077. And if I put that into the function, so I'm going to hit the highest point at 0.077, and I'm going to get a height of about 14.87. So could even reduce that range, maybe make that 16, because the max height is going to be under 15 centimeters. So I'll see the whole graph by using this kind of a window. Okay, C, what is the height of the spider 0.5 seconds after it jumps? Well, if I put in 0.5, I'm going to get negative 73 centimeters out. So I guess he's not going to really have a height at that point. So he will already have hit the ground at 0.25. So it's not like he's going underwater. It says he's going to hit the ground. So this is the result of plugging in 0.5. I'm not sure if that's a typo, and maybe it was meant to be 0.05. But that's the result you get.